Here's the type that starts the transaction PA10, the click that activates the button, and the actual pressing of the button. First, let's test it. Okay, looks like it's working. Let's take a closer look to see how. As you can see, the only difference between the two clicks are the offset coordinates. The offset is calculated relative to the indicated element, or from its top left corner to be exact, resulting in a click that lands exactly on the button every time. For practice, let's delete these two generated click actions and recreate them manually. So, add a new click, indicate the text field, and duplicate the activity. The default click position is in the center. We'll change that to the bottom right corner instead, because it's closer to the tiny button, and add an offset of a few pixels. -5 pixels on both axes should be okay. In case you're not familiar with screen coordinate systems, positive axes are to the right and down. So that's how you interact with ephemeral UI elements, by simulating human actions that activate the desired element. Further on, let's see how to expand these folders and click the associated checkboxes. Automatic recording won't work because individual elements are not accessible, so we have to fall back to the click text method used earlier, but with an offset. Start by going to text mouse click and indicate the area. In the lower box, we'll copy the text we want to click next to, personal data, and to offset the click, use set mouse position. Manually indicate the position on the little expand arrow, and that's it. Hit continue, and the click will be performed. Then repeat the process for the other two checkboxes. Add a click text, copy the name of the element, and set mouse position, this time indicating the checkbox. On the right-hand side, most of the elements are accessible through automatic recording, but these specific text fields don't trigger an input field. It's no problem. We'll just manually add a type action for each field. And a few more. A click to accept the changes. A double click to choose an employee, and another click on the View button. In this screen, all the fields are readily accessible, so we can get any piece of data we need. No issues here. But there are some controls that can be a bit tricky to extract: tables and checkboxes. All individual table cells can be read, but what happens when you want to extract a whole column or the full table? To see that, we'll first start from a single cell. Let's save and exit for now and take a look at what we've recorded. The first action clicks to the left of the personal data text found on the screen, on the expand arrow. The negative offset on the x-axis is a good indication of where it performs the click. The other two are similar, but with a positive x offset, which means they will click to the right of the indicated text on the checkboxes. The next ones are simple type actions, clicks, and a couple of get values. It's pretty standard. The last one, though, it extracts a table cell value, and we'll use it to extract a whole column or row from the table. For easier testing, we'll cut it from here and paste it in a new sequence. Perfect. If we take a look at the selector for this get value activity, we notice the row and column are explicitly written. That's quite handy because it means we can use a while loop to cycle through all the rows in the table. So add a do while, set up a counter for it, and move the get value inside the loop. Now open its selector, locate the table row argument and delete it. In its place, simply put the counter variable. Oh, and remember that numbering of rows and columns starts from 0, so the first row is row 0. Okay, now add a write line to print it all out, and run. And here they are. Of course, you can apply the same method for multiple columns, or for rows, or for whole tables that you can extract and use further however you want. A special case for this extraction technique is when you don't know the number of rows in the table. Well, what then? Well, the solution is a bit counterintuitive, but it's also quite simple. It's based on the fact that in SAP, you can't read outside of a table. There's nothing there. So, if UiPath tries to read after the last row, it will throw an error. And here's how to exploit that in UiPath. Modify the do while to make it loop forever. Then add a try catch activity. And move the entire do while loop inside the try block. Technically, that's all. Now, when the counter goes beyond the last table row, it will encounter an error that will be caught by the catch block, so it won't actually fail. We'll also give the get value activity a shorter timeout, because its failure is what will trigger the catch. Then, add an all-encompassing system exception. And just for illustration purposes, throw in a write line activity. And when we run, we see the results, followed by the catch message, which means everything went smoothly. And the other element that requires a bit of special treatment, the checkbox. You can click it on and off and use regular recording, but to get its state, you have to read its attributes. It's fairly easy. Use the aptly named getAttribute activity and indicate the checkbox. UiPath will read and expose all its properties, but the one you're interested in is this one, checked. Then create an output variable, we'll call it checked, and show it in a message box. And here it is. Okay, as you've seen, output methods are pretty easy. All elements are accessible in the usual manner. You only need to set up some loops for tables and get attributes for checkboxes. And this brings us to the end of today's training. I think that by now you'll agree that SAP is generally straightforward to automate, with a few quirks here and there that have simple workarounds. The main takeaways of this video should be these. When automating SAP, start with recording the actions. Most of the time, it'll work fine. To interact with unrecognized elements, you can use click text and click image and keyboard shortcuts to reach difficult buttons or menu items. When dealing with an elusive UI element, like the tiny button to the right of some text fields, simply find a way to recreate the actions a human would do to activate that element. For tabular data, you have to use loops, although that's hardly SAP specific. The interesting part is the special case of reading a table of unknown size. The technique you saw was to read each row in an infinite loop until the operation fails. All that in a try-catch block to prevent an actual failure. And for reading special elements, use the getAttributes activity. It shows a bunch of hidden information that can prove very useful. And that's about it. Till next time, goodbye.